Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to predict the extent of a reaction. So basically what you want to do is you want to use the equilibrium constant of a reaction to determine how far does the reaction go. Does it favor the products or does it favor the reactants at equilibrium? So basically, in other words, at equilibrium, when the reaction reaches equilibrium, are you going to end up with a whole bunch of product and a little bit of reactant, or are you going to end up with a whole bunch of reactant left over and a little bit of product formed, or is it going to be more in the middle where you've got maybe an equivalence of each to some degree, right? Where neither side is favored. So that all depends on what your K value tells you. So that's what we're going to go over in these example problems. So here we're asked to predict whether each of the following reversible reactions favors reactants, products, or neither at 25 degrees Celsius. I want to point out that we're specifying the temperature because the equilibrium constant depends on temperature. If you change the temperature, then the equilibrium constant will change. So the equilibrium constants that you're given here for each of these four reactions is at 25 degrees. If it wasn't at 25 degrees, these would be different values. Okay, that's the first thing. The second thing I want to remind everyone is that generally speaking, what we need to keep in mind is that generally speaking, it's an oversimplification, but for the purposes of this video and be able to predict an extension of a reaction, you have to remember that the equilibrium constant is basically the concentration or pressure of the products over the concentration or pressure of the reactants. So if you can remember that, then you can understand what each of these K values is telling you, right? So at equilibrium, if K is large, right, at equilibrium, then that means that you're going to have much more product. You're going to have more product on the top and little reactant on the bottom, therefore making this a large value. So this is a ratio of product to reactant. If you remember that, then that makes the understanding of where the equilibrium lies, is it favoring products, is it favoring reactants, or neither, makes it simpler to understand. So understanding that K is a ratio between products and reactants indicates that, well, okay, if my numerator is large, right, and my denominator is small, I should end up with a large value of this ratio. If I have a large denominator, which is reactants, and I have only a little bit of products, which is the numerator, then this value of the ratio is going to be small. And if they're relatively close together, then my K value is going to be close to 1, right? So that is key to understanding how to predict whether or not your particular reaction favors reactants or products or neither. So let's go ahead and look at these reactions and their K values. So here we have CO gas reacting with chlorine gas to give you CoCl2. And we're given the Kp value at 25 degrees is 6.5 times 10 to the 11. Now that's a very large number, right? So given that K is generally speaking product concentration over reactants, or in this case, we're dealing with Kp, so it's going to be pressure of products over pressure of reactants, right? Then that means this large number tells us that we have a very large numerator and a small denominator, relatively speaking. So therefore, that means that at equilibrium, this reaction favors products because it's got a very large Kp. So here I have written here, so K being larger than 10 to the second power or 100, that means that products are going to be favored at equilibrium. Let me fix this here. Equilibrium. If your K value is less than, say, 10 to the negative 2 or 1/100th, then that means reactants will be favored at equilibrium. And if your K is in between those values, then neither side, neither reactants or products are favored. So in some textbooks, it'll say K less than 1, or and then here it'd be, okay, if K is greater than 1, products are favored. If K is less than 1, reactants are favored. If K is equal to 1, then neither is favored. But this kind of gives it more of a range for that. So K could have a range where pretty much neither side is favored. So here we said that this is very, very large, much larger than 10 to the 2. So therefore products are favored. So let's write that down. So here, I'll write it here. So P favored, P for products. Okay, what about this reaction here? So this reaction, C2H6, decomposes into C2H4 and hydrogen gas. And so we have Kp is equal to 1.2 times 10 to the negative 18. So the fact that we have a negative exponent here makes this very, very small. So this is much smaller than 10 to the negative 2. This is telling us that we have a very large denominator compared to the numerator. And so this value here of the ratio ends up being very small. So this tells us that the reactants is favored. We have more reactants, much more reactants at the equilibrium than we do products. So here R is favored. For the next one, we have 2NO plus oxygen gives us 2NO2. And so this reaction has a Kp value of 2.2 times 10 to the 12th. So again, a very large positive exponent tells us that this is a large Kp. And so that tells us that at equilibrium, we have much more product compared to the reactant. So the numerator is much bigger than the denominator. So that gives us a large K value. That means that product is favored. We have more product at equilibrium than reactant. So product is favored. So we're going to write P is favored. And finally, we have D, 2NO2 gas. These two react together to form N2O4 gas. And so here we have kind of a synthesis reaction going on here. And here the Kp value is 6.7. There's no times 10, it's just 6.7. And so that's really close to 1. It falls in the range of being greater than 1/100th, but less than 100. So that means that for this, neither is favored. So neither P or R, neither product or reactant is favored. And that, ladies and gentlemen, is how you determine to what extent your reaction is going to go. Is it going to go pretty much to completion and therefore very favored to products? Or is it going to not really go that very far and not produce very much product, and therefore favor reactants or not favor either side? So it all depends on what your K value tells you. So I hope this video helped you a lot. If you enjoyed this video, then please like the video, share the video with your friends, hit that notification bell, the like button somewhere over here. Notification bell, yeah, you should hit that too, but subscribe to my channel, then hit the notification bell, and then click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section, please. Let me know what you think. Ask me questions. I would love to hear from you. Also, if you have a problem or a question you want me to go over, I would love to do that for you. Just put it down below. If you have a topic you want me to cover, I would love to do that for you. Just put that down below in the comment section. Thanks for joining me and have a great day.